Hello, everybody. Yet another back with another virtual session of InfoSec Girls. So today we have another speaker, Jyotsna Adhana, and she would be walking us through the buffer overflow attack, one of the DOS attacks. Speaking about her, she is a very vivid learner, a security enthusiast, and a pen tester. Currently, she's working as technology security analyst in Accenture. So over to you, Jyotsna.
Thank you, Samal. That was such a warm welcome to me. And I am very much excited to deliver the session on buffer overflow attack. And just want to thank InfoSec Girls team to giving me this opportunity. And I just hope in such a COVID period, everybody is safe and sound. Okay, so let me just share my screen. Fatima, can you see my screen?
Yeah, I can see it.
Okay. 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 So as we know, we are going to discuss about the buffer overflow vulnerability. So as buffer overflow is a vast topic altogether, so we will try to cover its basics. And even if you will look for the another scenarios, the logic will remain same. And specifically for the aspirant whosoever is preparing for the OSCP, this session is going to help them. As in the exam, 25 marks, a huge number is dedicated to buffer overflow machine. So before going further, let me introduce myself, like who am I? So as Fatima has mentioned, like I'm a technology security analyst at Accenture right now. So, and coming to the work part, like I have worked on web, mobile, network, and API as of now. And since my college days, I have been working on multiple projects. And Vibhrishti is one of the initiatives that has been taken up in the field of security. So you can visit vibhrishti.com to know more. And you can connect with me via LinkedIn and Instagram. So, okay, let's quickly discuss the agenda of the session of today. So we will, before understanding the buffer overflow attack, let's try to understand what is buffer, then buffer overflow attack. And later we will try to understand the anatomy of the stack. And we will be going to discuss ESP, EBP, and EIP registers. I will be showing you the prerequisites that I have taken up for the demo. And I have made the video POC so that it will help you to understand much better. And before that, we will discuss the basic methodology that one should pursue in order to perform buffer overflow attack. We will see what could be the conclusion, and later I will take up the queries. Okay. So let's try to understand buffer in a very basic terms. So buffer is nothing but just a temporary space which gets created in computer's memory to store and patch the data from the stack. And when we exceed that limit assigned in the buffer, it results in buffer overflow vulnerability. And in the successful buffer overflow attack, the malicious user can craft a malicious script which can take over the entire victim machine. So let's discuss some possible losses due to the buffer overflow attack. So it could be result in the remote access and the system gets compromised. Disablement could be temporary or permanent, and that critical information could be altered, exfiltrated, and destructed. So in and all, we would be having the full access to the victim machine. So So this is the diagram, and I will try to explain using it. So let's try to understand more deeper the anatomy of the stack. So the very first one is ESP, the extended stack pointer. So this whole is a stack basically. And the ESP stands for the topmost value of the stack. And the EBP is extended base pointer, and it represents the bottom value. And the EIP points to the next value to be executed. Means the next instruction that we want to execute, we can do that with the help of EIP register. So the standard says is the inputs provided by the user should be in the buffer space. Here, it should be in the buffer space. It should not exceed that limit. But in a successful buffer overflow attack, the inputs provided by us will exceed the limit, and it will overwrite EBP and EIP. So for the demo purpose, like I have taken up the Windows XP as a victim machine, and the free float HTTP version 1.0 is up and running in Windows XP. And of course, we will need the attacker machine. I have chosen my Kali Linux in order to do that. And lastly, the Immunity debugger to debug the vulnerable software. So I will show you the video POC, but let's try to understand some basic methodology that one should consider it in order to perform buffer overflow attack. The very first one is the fuzzing. So in the fuzzing, we as a malicious user send bunch of characters to the vulnerable part of the program to see whether we are able to break it. And in the second step, we used to see at what point we did break it. And we used to find out that offset value. In the next step, we will try to override the EIP. As I had showed you in the EIP, like it's the next instruction that is going to be executed. So what we want to do here basically is to execute our instruction or exploit to the ESP register. And in order to do that, we should control the EIP. And in the next step, we will try to find out the bad characters. Okay, so bad characters are some characters that destroy the normal execution of the program. And in order to make buffer over attack successful, we have to remove them from our exploit in order to, execute the exploit better and successful. And post that, we will generate a shell code. In shell code, we will be providing the IP and the port by which the victim machine will get connected to the attacker's machine. So here, I just want to highlight some of the points, like there are two types, the staged and the stageless payloads. So I have used stageless, the payload that without the metasploit. That is not the metasploit one. You can try the same attack, the buffer overflow, with the help of metasploit. But right now I'm doing using the stageless payload with ANSI, the netcat command for listener. And after that, in the next step, we will try to find out the right module, because like you can understand, like we have controlled the EIP, right? The next instruction. So now we want that instruction to be executed to the ESP. So in the right module, we will try to find out the jump ESP address. And if everything goes well, we will get the shell of the victim machine. So let me show you the POC that I have made. So this is the Windows XP, the victim machine that I have used. So it is running on the port number 21. The Linux is the attacker's machine. So we will quickly find out the IP address of the victim machine, the XP machine. We will copy it And in the attacker's machine, using the nmap, we will put up the victim's IP, and it will, the S stand for service and V for version. So here, the free float version is, we will check whether it's vulnerable. We will check the exploits available using the search exploit. So these are the number of exploits which are available over here. So, okay, so using the search exploit, you can find out the number of exploits available against the free float or any other vulnerable program. So, but for this demo purpose, I have already downloaded the exploit code, and I have made it. I will show you in a bit. So, okay. So let me pause for some time and let you help you understand like what is written over here. So the very first line is the interpreter path of the Python. The second and third line, we have imported the socket and sys. A socket to make the communication between the two systems, and sys for the command line arguments. The fifth line case is the A's, if you could recall it from the anatomy of the stack slide, like we are providing the multiple outputs. We will check how, like the very first step is like we are throwing a lot of input over there in order to check whether it's vulnerable to buffer overflow or not. So that is the buffer we have taken up, and in 6th point, we are making the connection. The sock stream. Sock stream is for the TCP connection. In the 7th point, we are connecting to this is the IP of the victim machine and the port number, the 21, if you can recall it previous. And for the FTP, there are two parameters, the username and password. So we are just receiving in and sending it, and we are just closing and connection. So this is all this written exploit is doing. Okay, so we will quickly save it and run it. Okay, so we will open up the immunity debugger. It's if you can recall, it's for to debug the vulnerable software. I will open up the FTP server exe file, and I will run this program. So if you can see the A's that I had provided, so it is overwriting the ESP and the EIP. So this is 4 times A. So the hex value of A is 41. So the 4 times A means the 4 times 41, right? So we can see that it is overwritten, and we have successfully break it. So our first step, the fuzzing, is completed at here. So the EIP and the ESP. So we will rerun it. We will go to our second step for finding the offset. So that contains the 2 steps. First, we will create the pattern, and post that we will try to find out the offset value. So I'm just going into that directory. So I am creating that random pattern of 1000 length. Here I'll stand for length. I will open up my exploit code and paste that random generated string over here instead of A's. We will save it and rerun it. we will copy this EIP. We will be needing that in order to get the offset value. So I'm just copying it. Of length of 1000 and Q is for the query. So, okay, so let's try to understand this. At 230 is the offset value. That means is like why we are providing the EIP, because uh, before the EIP, that buffer space and all that stuff comes under that limit. So this is the value at which the application is breaking. The 230 is the offset value. So we have successfully completed our task, the second step. Now the third step, we will try to control the EIP. We will overwrite it. So here we confirmed, right? Like this is the capacity of the buffer, the 230. Okay. So after that buffer space, we will be trying to control the EIP. So if our institution is right, so that B will be overwriting the EIP. So let's just quickly check that. We will rerun it and we'll check. Rerun the program. So the hex value of B is 42 and 4 times 42 means 4 times P. So that means like we are able to control the EIP. So our third step is done from here. Okay. So the fourth step is for finding the bad characters. We will get the list from both security. This is a great site where you can just copy the list of bad characters. We will copy it and we will be using that in our code, in our exploit code. We will quickly open up our exploit code. And we will append that value to the buffer. So I will remove the x00 because that is the universal bad character. We will save it and we'll rerun it. And we will dump. So that bottom left is this box is helping us to dump the values, and we will quickly check that. So here that after 09, it should be 0A, but it is coming as 2E. So that means this is suspicious, and that 2E. So I'm coming to the conclusion that after 09, whatever character is there is a bad character. So I will remove that too. I will open it. So that is 0A, and I will remove it. I will save it. I will rerun the program and rerun the exploit. We will again dump the ESP and we will see now. Now after 0B and 0C, it should be 0D, right? But it's 2E. So again, after 0C, whatever is there, that is a bad character, and we will remove it. Okay, so we will save it, rerun the program, and we will rerun our plug. So lastly, we have checked also, like the last value is FF. That means our shellcode is free from bad characters. And that is great news to us. So our fifth step for generating a shellcode, for removing the bad characters, that is done. And we will remove it again. Okay. So I have added the X90, that is the knobs. So why we are, the knobs stand for the no operation. That means we want our application to rest for some time. It is totally optional, but it is always recommended to do so. Okay. So as we know, like our list is free from the bad characters, and now we will be generating the shell code. I am generating it with the MSF Venom. The P stands for payload. So as I have mentioned before, I'm using stateless payload. So we are making a reverse connection to the victim machine. So we will be providing our IP. For that, we will check our Kali machine IP. We will copy it and put it back. We will be providing the port number of our choice, that F stands for format and C for in what format. I have chosen C. You can choose any of the language you want. And B stands for the bad characters that we had removed. We need to mention it here. So this is the code free from the bad characters, and we are able to generate a shell code. We will copy it and paste it in our exploit code. Yeah. So again, we will rerun it. Okay, so the shell code is done, the fifth step. In the next step, we will be finding the right module. So I have integrated the Mona modules with the immunity debugger in order to do that. So I'm searching here for with the Mona modules. Okay. So in the screen, if you can see the ASLR, these are the protections that you need to check. The more the protections are disabled, the good for us, for the attacker's point of view. And for the user's point of view, it should be enabled for the security purposes. But here we are doing the attack. So it's, we will be looking where the protection is less. So I have just selected this DLL. I will go to the executable modules and I will select it. I will check for the jump ESP address. So just copy it.
Jyotsna, I can see that you are there, but then Jyotsna, can you hear me?
Yeah, Vanna, like, can you hear me?
Yes, I can hear you, but I can't see you.
Okay.
Neither your screen.
Okay, can you see my screen?
Yes, now we can see your screen.
Okay. Okay, so we were here. Okay, let me. So I was here and explaining that address, it should be in the reverse address. So we will put the listener on port 4444, the same port that we had used while the MSF went in. And we are successfully able to get the shell of the victim machine. So that is all about the demo. Moving further, let's discuss, comes to the conclusion of the session. Like we should use the IDS and IPS protection systems, IDS for detection and the IPS for the prevention. On the very periodic basis, we should be doing the source code review for the applications so that if any vulnerable components are getting used, it should be figured out, and we should perform the actions accordingly. And as I had mentioned, if you can recall in the video, in the mono modules, these were the protections that EEP, ASLR, and CHOP. So it's good if they are enabled. So let's me quickly explain you like what these protections are all about. The DEP marks memory as non-executable. So if the process try to execute in the DEP protected memory, that process will get terminated and exception will be thrown. But but there is some limitation. But if the attacker gets a root access, the DEP is also hackable. For the ASLR, as you can understand by its name itself, like it's for randomization. So in the ASLR, it selects a random memory location and just assigned it to load window exe and DLL images that I had showed to you. And it's in an unpredictable location. So it's good if these protections are enabled. And the C-hop for basically it detects if anything suspicious comes up. It detects the changes in SEH. So we should never trust the user inputs. This is for sure. We should always take care of that. And if you want to learn more, this Korean link is there. Like you can understand this. The stuff is really nice. So you should check this out. And especially if you are preparing for OSCP, you can solve multiple challenges like World Server, Brain Pan Machine, from World Hub. And there are a couple more. You can find it out over the Google. So these are some references that I have personally gone through, and these are amazing. So if any question, we can go for a Q&A. Any queries?
That was a great session, Jyotsna. And we would be taking up the questions at the end of this session, for today's session. So we'll let you know if you'll have any questions regarding to your topic. So thank you so much.
Thank you, Saman. Yeah.
Everybody stay tuned for the next live session. That's with Arushi. So stay tuned.